Hello, everyone. In this session, we're going to discuss AgentCore Gateway and how it allows you to transform your AWS Lambda functions, API integrations, and our custom code into secure MCP tools for your AI agents to consume. In my previous video, I mentioned that Amazon launched a new service, which is currently in preview, called Amazon Bedrock AgentCore. And we reviewed that AgentCore simplifies building, deploying, managing, and securing of AI agents at scale. We also discussed that the value of AgentCore is it works with any agent framework and any foundation model, not just Bedrock hosted models. Today, I wanted to focus on Bedrock AgentCore Gateway. And AgentCore Gateway is a managed service that transforms your APIs, Lambda functions, and other AWS services into model context protocol compatible tools that AI agents can discover and use. So it acts as a secure bridge between your AI agents and your backend resources, handling authentication, protocol translation, and tool orchestration. And best of all, it's pretty easy to get up and running, thus eliminating weeks of custom integration code. So consider traditional MCP deployments. They require you to handle server deployments, authentication, scaling, and monitoring all by yourself. But AgentCore Gateway provides all of this as a fully managed service, thus eliminating the operational complexity of running MCP servers. So for our project today, we're going to MCP enable an AWS Lambda function and secure it with authentication and integrate our Lambda function as a tool into AWS Strands AI agent. Let's jump into our demo. For that, I'll go into our AWS console. Okay, I'm in my AWS Cloud Console, and I created a basic AWS Lambda function called test Lambda. And in this function, I have a couple of hard-coded methods called getWeather and getTime respectively. So if the tool name equals getWeather, then it returns 72 degrees, partly cloudy, and a variable for humidity. And if the tool name is getTime, then it returns 1500 hours, which is also hard-coded. And a key element of this code is that AgentCore passes the tool name through the client context with a specific format, and that's what you're seeing here in the highlighting. And I have a couple of test events defined to invoke my function. So let's give this function a test. All right. Okay, so I'm passing it a tool name of getWeather, followed by a location of New York. And I'm going to go ahead and invoke this test. And based on this test, you see the hard-coded variables that it returned with the temperature of 72 degrees, partly cloudy, and a humidity of 65. Now, let's also invoke our getTime, which is our second test event. And I'm basically going to pass it a time zone of Los Angeles. And I'm going to say test. It's always going to return 1500 hours regardless of what city time zone I pass it. All right, so let's MCP enable this Lambda function. For that, I'm going to go into my integrated development environment. Okay, I'm in my integrated development environment, and I have a script that I created called create gateway with targets. And what this script does is it creates an OAuth authorizer using our AWS Cognito service. It's important to note you can use your own custom authorizer as well. In this case, I specified that the authorizer will be called Lambda authorizer. And once our authorizer is created, the next step is to create our MCP gateway. And I'm going to call the MCP gateway Lambda MCP and configure it to use our OAuth authorizer we created in the previous step. Now that our authorizer and MCP server exists, we'll want to associate the MCP server with our AWS Lambda function. So first, we define the tool schema that follows the OpenAPI convention. So you notice I'm mapping our methods that were contained in our Lambda function here along with the required inputs. And we pass our gateway, the Lambda function name, the function ARN, along with the schema we defined above, and we also save these variables in a file called gateway config.json. So let's run our script, and note this process takes about a minute to complete, creating all these resources. Okay, so view terminal. Our script just completed. Let's go into the AWS console to view the AgentCore MCP gateway that was created. So I'm in my AWS console. I'll go into the AgentCore service. And in the left-hand menu, I'll click Gateways. And you notice our Lambda MCP gateway was successfully created. We clicked on it, and let's observe the configuration. We see our gateway details. This is what we're saving as environment variables in the gateway config.json file in our IDE environment. And we also see our Cognito OAuth authorizer, and we see our targets, which is mapped to our AWS Lambda function. Now let's test our MCP gateway. For that, I'll go back into my IDE. Okay, I created a predefined script called test_gateway.py. And what's happening here is it reads our configuration variables that we saved to gateway config.json from our previous steps. And it gets the authorizer and MCP server info and reads those variables in. From there, we get a bearer token from our OAuth authorizer, which was our AWS Cognito service, and we add that bearer token to the header of our request. And we're making a post request where we're predefining the payload to make sure our MCP gateway returns a response. So here we're stating that we'll call the get weather tool and send it a location of Seattle, and it should return the same output that our Lambda function returned when we tested in the previous AWS console test. So let's run this script. And let me maximize my... And great, you see that we received the response from Seattle with the temperature of 72. Conditions were partly cloudy. Humidity was 65. Again, remember we hard-coded this in the Lambda function. We're not calling a real weather API. So let's flip to our slides for a minute. We create our interactive agent. Let me review this architecture. The goal of an AI agent is to bring external context to an LLM through integrations. In this case, our MCP gateway is using our Lambda function as a tool. So we've abstracted tool delivery to be API driven versus directly coded into an AI agent. Now we'll create an AWS Strands agent that calls the respective tool based on queries. What's compelling about this approach is traditional MCP servers often run locally and require you to trust and execute the code directly on your client machine, which can create security risks. Traditional MCP servers also lack built-in authentication, so there's no standard way to prevent unauthorized access to your tools. The AgentCore Gateway approach provides an enterprise OAuth authentication and runs the tools in an isolated Lambda function rather than on your local machine. MCP decouples your tools from being directly coded into agents. And with that understanding, let's perform our final step, creating the interactive agent. Let's go back to our IDE. Now for the fun part. Let's create an AI agent that can use these tools. I have a predefined script called Agent with Gateway. Let's walk through this code. Notice we read in our gateway config JSON to load our necessary environment variables. We then get a bearer token from our authorizer, and we'll pass this in to our header. Notice we're using the streamable HTTP client versus standard input-output, and we'll define our model information that's coming from Amazon Bedrock, and we'll pass this in to our MCP client. Let's execute the script and try a couple of test queries. I'm going to maximize this. Great. So first I'll ask, what's the weather in Miami? And you see how the agent is automatically choosing the right tool and formatting the responses? That's the power of MCP. The protocol handles all the tool discovery and the calling for us. So now we'll ask, what time is it in Chicago? And again, routing to the appropriate tool, and it's giving that same result that we're getting from the Lambda function. Remember, I hard-coded both the weather and the time just for the sake of a quick demo. Okay, this concludes our demo. I hope this was helpful. I'll upload these scripts along with any other notes to GitHub. And thanks for watching and happy building. Take care.